Oh, hello there. Shh, don't be frightened. Once a year spookiness takes over your quaint little chemistry podcast. But not to worry, I won't be here long. And you look like you could use some spooky in your day. So sit back, relax, get in the spooky spirit, and let's listen together. Perhaps over a nice, warm drink.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life, Spooky Edition.
The podcast that very spookily helps you understand the chemistry of your very spooky life just this time of year.
Jam, it's Halloween.
Yes.
You know how much I love Halloween.
I do know how much you love Halloween.
Last year we did that crazy cool fire flamethrower and green fire pumpkin situation.
Oh, yeah.
It was great.
And I think last year, not quite as chemistry related, I think you got me, I don't know if anybody else hadn't seen it. I'd never seen the movie Hocus Pocus. And you got a lot of us to watch that. So that also helped me understand your love of Halloween and how much you want to spread that love to other people.
Yes, it's just fun. It's just a fun holiday where you get to do fun stuff. And I like to bake. Usually I bake a Halloween cake, although this year I'm doing a no sweets situation. So I don't know if I'll be able to. And
there's got to be some other Halloween themed things you could eat that are like not sweets, right? I mean, come on. We got to be able to find some healthy Halloween options.
But I just like to make cute little cakes, you know?
Yeah,
so.
Totally.
So I just love Halloween, and I'll post some pictures of my previous Halloween cakes that I've made.
That's a good idea. Those are,
That's what I'll do.
Melissa hasn't had a lot of opportunities to talk about how good she is at baking, but this is a good opportunity for you to try your stuff because I've been on the both tasting and seeing side of some of these cakes, and I'm like, how'd you do that?
Well, my Halloween ones are pretty simple. One was the first fancy cake I ever tried to make. And one was I just got creative with sprinkles because I was making a box cake at the last minute, but I just like to make a cute Halloween themed cake. So I'll post some pictures of those. This year's maybe going to be a little bit weird, but I still want to do a Halloween-y theme.
Okay.
So we're going to be talking about glow sticks.
Oh, nice. Okay, sweet.
So how do glow sticks work? What's going on? That's definitely chemistry, okay?
Okay, great.
So I'm going to give you that lesson, and then I have some fun facts for you about glow sticks at the end.
Excellent. I love this idea. I love fun facts. I love all of it. And I'm kind of coming around to loving Halloween, maybe, so.
Well, if nothing else, it's a good reason to see little kids dressed up in cute outfits, which I think is really fun.
Yeah.
And normally we get to give them candy and stuff. I don't know what the deal for social distance trick-or-treating is going to be this year, so I'm kind of sad about that. It's going to, I think, be a low-key Halloween, but
yeah,
maybe next year.
Yeah, I've seen some people post some ideas about how to try to get candy to the kids and stuff like that, but it does end up kind of removing some of the fun interactive parts where you get to say, oh, I love your costume and all that stuff. So I think that it's a little bit of a bummer, but
yeah, definitely
can't be helped.
Okay, so a long time ago, we talked about how within molecules, electrons will absorb energy and emit energy.
Okay, right.
And the way I think it's best to describe it is if you imagine two electrons hanging out on the bottom step of a ladder, and then one of them accepts energy and jumps up to a higher step on the ladder. And then once it gets tired of hanging out at that higher step, it falls back down to the original step.
Okay.
And in that process releases energy. So in chemistry, we call the bottom step the ground state and the higher step the excited state.
Okay.
So we'll say electrons will absorb energy and go to the excited state, a higher energy level, and they give off that energy and come back down to the ground state.
Okay.
I tried to think of a good analogy for that, but I feel like it was kind of hard because we use energy to go up. We don't accept energy to go up. And then we stop using energy. You know, if we're climbing up a rope or a rock wall or something, to get to the next level, you're using your energy. And then you kind of give up and you're not using energy anymore when you come down. So it's kind of different. I thought maybe you could come up with a good analogy for that.
Yeah. We've used the sugar rush analogy before, which is a little bit like that because and so I didn't come up with that obviously, but you accept energy by eating lots of sugar and then you are hyper. But the downside of that analogy is I guess that when you're hyper as a kid or whatever, you are also expending the energy, but that might be kind of like it because you start to come back down as you expend the energy. But that's what immediately came to mind again. I've had forgotten completely about us talking about that before. And then you started saying the latter thing. And I thought about sugar and kids and because Halloween.
I was writing this episode over. I was with my significant other. He was working on something else. And I tried to think of something and I kind of bounced some ideas off him. And the thing we came up with was eating food. So that's pretty similar to the sugar rush. So you eat food, you have this energy, and then you expend that energy to go back to a state of being hungry. Yeah.
Especially whenever you are really, really hungry already, you do feel like low energy. I mean, you feel like you're in that ground state. And then as long as you don't overeat and then get like tired from eating, I feel like that is what happens. We feel like a boost, like revitalized by having just accepted energy in the form of delicious food.
Yeah. Or maybe sleeping. When we sleep, we accept energy and then we're awake in our awake state, excited state. And then we come back down and need sleep again.
Yeah. That works.
But I feel like the normal state is the ground state, and we don't think of ourselves as our normal state sleeping. So
yeah, that's true. That's true. Ours is more reactive. It's like, okay, we used a lot of energy. We got to do this so we can get some back.
Right. But I think that explains the general idea of what we're talking about here, where it accepts this energy and then it comes to this elevated state where the electrons are excited and they have this energy and then they release it to come back down. So essentially what's happening in glow sticks is you have a dye. So that's an organic molecule that usually has a lot of alternating double bonds. So it has that color. And it has the ability to absorb energy, but then release it as light. And that is what's known as a fluorescent dye. Okay, so that's the short answer is what's happening in a glow stick is you see a molecule accepting energy and then releasing that energy back in the form of light. Okay. That's what fluorescence is. That's a fluorescent dye. Is it releases that energy back in the form of light. But then the question is, where does the energy come from? Why do we snap that thing?
Yeah. And also just, it's kind of weird to think of like light is already how we see stuff in general. Like it's the things that don't glow. You know what I mean? So it's weird to think like, okay, it's different though. Like it's releasing energy in a way that's obviously different and glowing, not just a color that we see, but a light like is emitting, which is trippy still. If you really think about it more, I think it gets trippier to me anyway.
Yes. Well, and energy is absorbed and released in specific packets, like this specific amount. The way it was described to me is like you can only get 1 can of soda. You can't get like a can and a half of a soda, right?
Okay, right.
Because then it's not really soda anymore. It's like half a can. It's like sloshing around. You can't buy that at a vending machine. That's sort of how energy is absorbed and emitted in these specific chunks. Okay. And the energy that's emitted as light has the wavelength that comes as light, and it has that color as well. Okay. So that's a little maybe too far in the details. We don't have to get into it, but that's if you're really wondering and you want to know more. It's like these specific packets of light that happen to, or of energy that are released as light at this specific wavelength. Okay. So, but we have so many more questions. Like, where does that energy come from? Why do we break that thing inside of the glow stick? What is going on with that? Okay, so I'll tell you about that.
Okay, I'm down. I'm ready.
in the glow stick, you have two components other than the dye.
Okay.
Usually usually the hydrogen peroxide is contained in the glass.
Okay.
It's a glass tube inside of your glow stick.
Okay.
And that holds hydrogen peroxide in there. And then outside, mixed in with your dye, is another molecule.
Okay.
And what happens when you break the glass tube inside your glow stick is the hydrogen peroxide mixes with and oxidizes this other molecule. And the ultimate product is a release of energy as a byproduct from that reaction. And that energy that reaction releases is absorbed by the dye. And that's the energy that gets emitted by the dye.
Okay.
So you have these other things that don't have as much to do actually with the light that we're seeing.
Mm-hmm.
And they mix together. And as a byproduct of their reaction, they're releasing energy. And that energy is basically what powers the glow stick.
Okay.
That energy is absorbed by the dye to go to that excited state level. And then when the electrons in the dye come back down to the ground state, we see them emit light.
Okay. Okay.
And that's how a glow stick works.
Dang, that's crazy.
It is crazy.
Like when you word like that, I mean, obviously that is crazy. It seems more simple. And I'm sure that to a lot of chemists it might be that way, but it's glowing.
I know. The key to the glowing is the wavelength of the energy that is emitted from the electron. So it really is basically just these dyes have the special ability to emit light. They're just special. And they just need energy. So those dyes are, they would be able to do that if you shined light on them from a laser or from something else. But it just so happens that we need to power it a different way for our glow sticks. So we do that by a chemical reaction, releasing energy to power the dye, kind of. It might seem a little crazier to you that it emits light because usually things just reflect backlight. They don't emit it in the way that we see here.
Right.
But the reason for that is because you can't see most of the energy that's given off by excited electrons. So we talked about on the sunscreen episode, it absorbs the sunlight and dissipates that energy by releasing it as heat.
Oh, yeah.
In sunscreen. And a lot of times that's what happens is there's these small, almost imperceptible movements of the molecule or the electron that allows it to release energy. And it's very rare for the release of energy to be a photon of light that we can see with our eyes. That is rare.
Right.
So I think that's why it seems kind of foreign. To me, it seems like, oh yeah, everything just gives off energy and it just so happens that we can see this one. But I think maybe to someone who doesn't know all about how electrons are constantly being excited and coming back down and excited and coming back down to the ground state, that could seem more foreign is because you don't see it the same way that I've seen it on when we study molecules and stuff. We use the ability for electrons to be excited and come back down all the time. And we can observe that in different types of spectroscopy and stuff like that. But you don't have that same familiarity with it. So that's probably why it seems a little bit crazier is it's like, oh, I didn't even really know that electrons were doing this. And now we're doing it in a way that we can see it.
And so few things just do that on their own. That's like just so novel to be like, this liquid in this tube just started glowing and it was just normal liquid a second ago that just had a color, but now it is both a color and glowing. Just, I think it's part of what's so trippy about it.
Yeah. And it even says I used a quantitative analysis book to help me prepare for this. So it's like quantitative chemistry. And it even says in that textbook that it's pretty rare. Textbooks don't say that very often. Yeah. So it is not the most common thing. So it makes sense that it's like, wow, why is it glowing? But I think that kind of explains that it's a very rare phenomenon, but it is just a different type of energy being released. But that's going on secretly without us being aware of it all the time.
Yeah. Dang, interesting. I also did not know how they, like the breaking of the glow stick. Like the ones I think about the most time are like the really long ones that you like bend and then kind of pull your hand along it and you hear the cracks the whole way down.
Yep, that's a glass tube.
Yeah, I didn't know it was a glass tube. Like that alone is already like, oh, I just had no idea what it was. And I haven't used a glow stick in forever. So like wasn't probably really wondering that much. I was just, let's glow, you know? And
let's glow.
I was just ready to glow. And I
didn't see that coming at all.
That is just so interesting to me to think about the mechanics of that. Like, okay, we'll put this really thin glass tube in there that has this one chemical. We want to keep them separated all the way until someone's ready to glow. And then I don't know what else to say there too. They're ready to be in the Halloween spirit or whatever. So that's cool.
Yeah, I think it's cool, and it is pretty simple. I mean, if you get into the nitty gritty of, okay, this much energy is absorbed, and then this happens, and that's why it can emit light, I think that could get pretty complicated. But the basic mechanics of it, I think, are pretty straightforward. Is you need a power source so that the power can be accepted by the dye, get these electrons excited, and then as they come back down, we're seeing the emission of light. Okay. So that's it.
Wow.
Oh, also, I was going to say that different colors come from different color of fluorescent dyes. So they have different amounts of conjugation or whatever that allow them to absorb and release energy in different wavelengths.
Okay. So I remember as a kid there being like a few different kinds of glow sticks, like at least one or two that you had to shake instead of like break. Does this chemistry apply to all of those? Is it probably pretty similar process in all the different glow sticks?
I would guess that it's a pretty similar process. I don't know for sure the mechanics of those, but the general idea is that you keep these two components that react to release energy separate from the dye and separate from each other so they don't react too soon. And then you let them all mix at the right time.
Got it. Okay. Got it. That makes sense.
Yes. It's very fun. I knew the sort of basics of the idea behind fluorescent dyes. We actually, I'll talk about them a little bit more in your fun facts area, but I did not know how they kept these two things that gave energy separate from each other and how they reacted. I didn't know that. I didn't know what the breaking thing was about. It had never occurred to me to wonder about it until Halloween time.
So should I try to explain this back to you?
I think so. I think it's time.
Okay, so basically it sounds like there's two substances that when they interact together in a glow stick, they, as a byproduct of their reaction, a lot of energy is, I guess not really created, but like changing hands, kind of.
Yeah, changing hands is a good way. Yeah.
So, and that happens, and then the glowing is sort of the effect of that. But it'd be sort of like we talked about how we eat food, and that is us taking in energy. And so things are taking in energy all the time. People are eating food all the time. But what if there was a specific kind of food that you ate that did the same thing that's happening all the time, but instead just made you glow? It'd just be like,
that's pretty close.
You would take in energy, and then as you're expending the energy, just be glowing, and it'd be like really freaky to everybody. But it'd still be the same like sort of thing that happens in the sense that it's just that I took in some energy and I'm expending it, sort of come back down from the energy that I have taken in or whatever.
The only tweak I would make to that is the energy, different types of energy aren't what make fluorescent dyes glow. It's the dye itself that has the capability to emit it. So maybe it's like there's some people who, when they eat, everybody releases energy the same way. We all have our base level of metabolism rate, but for some reason they glow after they eat.
Got it. Yeah, so it's not the food itself. It's not like there's some magic thing about the food. Have to be about the people and their way of being able to emit the energy in a wavelength that is within the region of like emitting light instead of just like color or whatever.
Yes.
Okay. Man, where are those people?
I don't know. Sometimes when I get excited, my face gets really red and hot, but it's not like light, you know.
Oh, interesting. That actually be a kind of interesting analogy to think about, like when like those of us who blush or whatever.
Mm-hmm.
I think all of us could get like a red face, but some people that happens way more often than others.
Ugh. You always know I'm either mad or embarrassed or really upset if my face is red and my neck gets kind of like splotchy. Ooh.
Dang, that's a bummer because you can't control it. But
Yeah.
it's also kind
it's
of
rough when you're
fascinating.
teaching a class too. When I was new to teaching and there'd be like 200 people looking at me and I knew I made a mistake, it was
Oh, dang.
very scary. Okay.
Yeah.
Well, I think that is a pretty good representation. You did say they're emitting light instead of just color, but normally things don't emit color. They just reflect color back to us.
Yeah.
So they're emitting light instead of just emitting energy with these small movements or even heat or something that's not visible. The difference is they're emitting energy visibly, which is not the norm.
Emitting energy visibly instead of just having energy in the form of light hit it and reflect it in the form of a color. So
Right. Mm-hmm.
energy, like light's flowing around all the time from everywhere or whatever. But these guys in this case are emitting light.
Yes.
Their energy that they're giving off is in the form of light they're putting out, not just reflecting.
Yes. I think you got it.
That's interesting. That is like, yeah, that's just kind of crazy. And I'm still pretty fascinated by glowing. I mean, I think it's still really cool.
It is
one of those
really
things where I was always tempted to, like, if I had a thing of glow sticks, I was always tempted to use them all at once and just like it's just hard to save it. I was the one who
saved it. I wanted to save it. I was trying to save it for a good occasion, and then it was like too late. So
yeah.
Okay, so here's some fun facts. I think it's about to get even crazier for you.
Okay, I'm ready.
Okay, 1, rates of reactions can be controlled by heat. So we've talked about that with the onion episode. If you put some onion in the fridge, the reaction that happens that makes it hurt your eyes slows down. So because it's colder. Theoretically, if it was hot, it would be going faster because you're putting more energy in.
Okay.
So if you want to save your glow stick, putting it in the freezer is an option because it slows down the reaction that gives off the energy that emits the light in the end. It's not about the dyes running out of the ability to absorb and emit light. It's that reaction runs its course and then there's no more reaction to happen. So there's no more energy.
Got it. Okay, got it.
So putting it in the freezer slows it down.
Okay.
And then if you put it, for example, in a pot of warm water, you would have a much more intense glow because all of the energy would be being released at once, but it would have a much shorter lifetime.
Okay, yeah. Dang.
That's one fun fact.
Okay.
Second fun fact. So in this case, the way the energy absorbed from the first reaction into the dye is something a little bit different. It's not in the form of heat or light. Okay. It's absorbed in something that's known as an energy transfer. So there's these systems known as donor-acceptor systems where one molecule is already excited. Its electrons are already in the excited state. And they transfer that energy from that donor molecule to the acceptor molecule.
Okay.
It's a direct transfer. And in my research, we saw that same kind of energy transfer. Sometimes they call it excitation energy. It's the energy that it took to excite one electron. They just pass that excitation energy along.
Okay.
And it doesn't ever necessarily get emitted as heat or light.
Okay.
So it's just transferred. Almost as if you just give someone money from your bank account to another bank account. You don't spend it and then someone else gets it. It just is transferred.
Got it. Okay.
So in my research, we used donor acceptor systems with that same kind of energy transfer to try to mimic artificial photosynthesis and keep electrons excited so that we could transfer sunlight into usable energy for solar cells.
Nice.
Not only that, but this kind of energy transfer is also used to label something. I was a little fuzzy on the details in DNA sequencing. So they used lasers it's called laser-induced fluorescence, to label or mark, I wasn't super clear, DNA when they were sequencing the human genome.
Wow.
So in your hand, you hold a chemical reaction that generates the same kind of technology that's used in some types of solar cells and that's used in DNA sequencing.
Dang. That is complicated stuff. Jeez.
I know. And we use fluorescent dyes in a lot of stuff. They're really interesting and useful in research. So it's more than just that. But those are two, one that I knew personally, and another that in one of my organic textbooks, it actually talked about the DNA sequencing. So if you're a biologist and you know more about how they sequence the human genome, and you want to tell us exactly the role that the laser-induced fluorescence used, that would be awesome.
Dude, yeah, that sounds very fascinating. And one of those things I remember being talked about, maybe we'll have this done at some point. Maybe we'll sequence the human genome, whenever we were kids. And it's yep, they did it. It's just okay, that's crazy.
I know, it's wild. And you can interact with and see the same kind of technology. But also it's just cool because you're really and truly seeing the energy being emitted from a molecule. So, yeah, that's the chemistry of glow sticks.
Dude, awesome. I love that. That's very cool.
Me too. I was very excited to do this episode for Halloween.
Yeah. So while you guys are glowing, if that's part of your costume or whatever, and doing whatever you're going to do for Halloween, you're doing chemistry.
You are. And glow in the dark is another thing. I'm pretty sure I know what it is. I'll have to double check. So I'm not going to give you any spoilers or anything. But I think I'm going to save that for next Halloween.
Nice. Okay, cool. Also, what's cool about this is that even though, if you guys did not listen to the Green Fire episode from last Halloween, you definitely should. The cool thing is that in this case, this is something that you can do all you want. You can use glow sticks and stuff all you want.
Yeah.
Green Fire was super cool, but not safe for me or any other non-chemists to be doing.
Yeah, that's true. They have some experiments where you can change fire colors on the American Chemical Society website, but even that takes a lot of safety preparation, and you need to have your parents there and all this stuff. But glow sticks, they're pretty safe to use as long as you don't put the dye on your actual hands. You're in good shape.
And I will not tell any stories about how I did that as a kid.
Do not, because it's not good.
And yeah.
All right, well, I hope glow sticks make you happy. But in the meantime, was there anything happy that happened this week that you want to share? Something you want to share from this week?
Well, I don't have a clear happy thing, but I did think of another in our never ending quest to use less plastic and that whole discussion from our plastic series. I thought of another tip that I am kind of bummed I didn't share. And our friend Dr. Moon reminded me of this when she was catching up with the podcast and commented on one of our posts. And there is a company, this is just a tip for you, called The Grove, I think. And they do a lot of more eco-friendly, lower plastic use things that they either make or sell themselves or just direct people to different, companies that do that. And so we have bought a few things from them. One of the things I think that is pretty cool is we buy our toilet paper online from them, I believe. And it's a company that uses bamboo instead of traditional trees to make the toilet paper, which is great. But the simple thing that's if you think about it, pretty huge, because everybody uses toilet paper all the time, is that they do not package it in plastic at all.
Yes.
And so just that really cheap, thin, layer of plastic is all around the toilet paper. They just wrap the rolls of toilet paper in paper, in the same kind of paper, but just to shield it, And it just is one more thing that you can remove as part of something in your life that does not use plastic every single time. That's
great. I love that.
So check them out, check out that site, and just look for options like that. I think there's a lot of people, probably more than just some of the ones we've mentioned, that are very consciously trying to see little situations like that where you really don't need to use plastic in that situation.
Right.
Many other scenarios where we have to do some more, advancements or technology or whatever, more difficult to replace with a non-plastic option. But there's a lot of these options that I'm like, that's just so easy. Very, very easy.
Definitely. Well, mine is also not explicitly happy. It's a little mixed. So my mom's birthday was this past week, and, she had passed away in March.
Mm-hmm.
And so it was her first birthday without her here, which is sad and hard, a little weird, but I did get to spend time with my family. I saw my grandma, who I have not seen in a very long time, but
wow,
it had been long enough since we'd had an exposure and we wore our masks and we didn't hug. So we had the opportunity to go see her, and that was really nice. And then I spent the day with my dad, and some of my friends were really sweet and sent me really kind messages and little things to say they were thinking about me, and that really meant a lot. Somebody sent me cookies. Friend of the show and reviewer A. Hefner sent me cookies. That was really sweet. And so just knowing how that was a hard day, but also there's a lot of love left in the world and a lot of good things still going on. It was kind of a nice way to celebrate.
Absolutely. Yeah. That's really, I know what you mean though. That's like that mix of you're sad, but you get to spend time with family, you get to be loved on by friends, and that is a really unique feeling that, yeah, so it's not just happy or sad. Right.
It's kind of this is a sad situation, but lots of silver linings, So that was kind of a good way to celebrate that day.
Yeah, absolutely.
Well, thanks, Jam, for coming and learning about glow sticks, being excited about it, and giving some good analogies. That was really good. I really appreciate it. And thanks to all you listeners as well. We could not do this without you. And it really means so much to us that you want to come and learn about chemistry every week over and over again.
And thank you for teaching us, especially on a cool Halloween-ish themed episode. So thanks for teaching us all about the crazy chemistry that's going on in this thing that we all love and are already fascinated by anyway. Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. Things that you're curious about, things that you wonder about, things that you're like, I think chemistry's going on here. We want to hear those and turn them into episodes. Some of the best ideas and best episodes, at least in our opinion, are from y'all's questions. So reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to V. Garza and A. Kiwasong, who reviewed this episode.
See, that wasn't so bad. Thank you so much for inviting me in tonight. Do you feel all right? You're looking awfully pale. Here, why don't you lie back and rest your eyes a moment? Trust me, I think you need the rest.